Good afternoon, Alia, and good afternoon, Shamar. How are you guys this afternoon?
Okay.
Okay? All right. So today's session, actually, we're going to be doing it with a little twist. Our last class we had what? Could you remind me? Revision of functions and relations, and we did some mapping, right? What were the types of mappings? One-to-one, one-to-many, many-to-one, and many-to-many. Right. So remember I said to you that's one aspect of relation and function, right? There is also another aspect as graph. But before we can even go on to that, I will take you a little back to graphs and charts, right? However, we're going to be going through these graphs and charts, but at the end, you will be the one that's given me the description of these graphs and charts, right? From what you gather from what we would be doing. Great? So let's go to the screen. Good. So here, you will also be saying, telling me what you think the graph or a chart is. Alright? So pay close attention. Bear those things in mind so that at the end you can give me some information. So we will be using online for this session. And remember the last class I would have said to you, you can get some of working some exercises and practice work online, right? So we are doing this for this session so that you can see that it can be very useful and educational wise. Good. So here we have a graph, and this one here, it's a bar graph. So by looking at it, observe it well, and we will go through it and then you will give me your explanation. So we have some values here where we have some labels A, B, C, D, and E. It can be anything. It can be colors, if we represent it by the colors there, where A, we have the yellow, B, red, blue, C, blue, D, green, and E, pink, something like that, right? And how many yellows we have, how many blues, red, greens, or pink, right? So what we would have done is just create a graph to give you this information. As I said, some things I'm not going to be saying now because I want to hear it from you after, right? So if I am to give you this graph and I'm to ask you a question as in, how many yellows and blue, say marbles, there is in the sample altogether? 6 altogether. Shamar, would you agree?
Yes, sir.
How many yellows are there?
2.
And blues? 4. Right. So in all, if you had to put them together, you would have gotten 6. Good. Which marble appears the most?
Red.
The red. Which marble appears the least?
A or yellow.
Yellow or A, right? Which marble is half the amount of the one that appears the most?
E.
E, that is the pink. Okay, and which 2 marbles would add up to 11?
B and D, red and green.
red and green, right? So we would have used this bar graph, a bar graph given to you, and just to use it to describe or to read off what is happening on the bar graph. Right? Good. Tell me something about a bar graph. If you were to explain a bar graph to us, what would you say?
A bar graph is used to separate objects and can be used to find the total of numbers.
Please repeat yourself what you said first.
Bar graph is used to separate objects, and you can use it to find the total of numbers when adding.
Okay, all right. Keep looking at the picture though, and see if you could give me another description. Yes, Alia.
The bar graph really a bar graph shows you how many things there are.
Okay, it shows you how many objects there are, or
Yes.
what else were you going to say? All right. So even if you're saying a bar graph shows you how many objects there are or something like that, if I am to draw the bar graph, would I be able to draw that bar graph from your explanation? So if you had to explain it to us so that we can draw it, what would you say? What are some of the key things that you can look for there?
The numbers at the side, they have numbers inside, so you can see
They have numbers at the side, and you can have numbers at the bottom too.
yeah.
Okay.
Objects, I said.
Yes. What else? So we know that we need if you want to say a vertical line and a horizontal line, right?
Yes.
Where that would be called the axis. So we have the vertical axis, that would be the y-axis. If you notice at the top, you have y and it mark how many. You see that in the box?
Yeah. Yes.
Next to category?
Yeah.
Right. And then we have x, that is the x-axis at the bottom, the horizontal line, which is the category that is A, B, C, and D. But as we would have replaced that with the objects as marbles. Good. So we know we have an axis, a y and an x-axis. What else we can recognize there about a bar graph?
Each of the things have different values.
They have different value, but each of what have different values?
The marbles.
Okay. Picture it from the graph of itself. Explain from what you've seen on the graph. Shamar? What stands out in the bar graph? Sorry about that.
Using bar graph books, or you could call it, to draw it.
Bar graph box?
Books.
Books? Okay, graph books.
Yeah, sorry.
Okay. Not necessarily to draw the bar graph. All right. Do you notice that you have some things look like bars, like rectangular bars? Right? And what about the rectangular bars?
Yeah.
What you're seeing there. Don't worry the colors. They're in different colors, but what else about the bars? They're equally spaced. Can you see that?
Yes.
Right? They do not touch. So the bar graph, right? You have the bars, the rectangular bars, but they do not touch. And yes, it's a diagram that represents some information given, where we would have used number of marbles, and the bars would not touch each other, right, for a bar graph. Good. Now look at this. If I change my figures, you see the bars go missing?
Yeah.
Yes, miss.
So I am creating a bar graph now. Um, Great. So I can ask you some questions here. Which two categories are equal?
C and E.
C and E. Which category appears the most?
B.
Pardon me?
Category B.
B. Which two categories would add up or sum up to 9?
B and C.
B and C. Do we have any other?
B and E.
Or B and E? Any other?
C.
To 9.
Yes.
B and D.
Pardon me?
B and D.
B and D. Would you agree, Alia? With B and D?
No, because
Okay, what else? Any other one?
A and D.
A and
D.
A and D. So in this case, you had different options, right? Sometimes you might only have one option. So here again, what's the difference? What would you have observed about the bar graph?
The bars are equally spaced.
Equally spaced. What else? Because if they're spaced means that
They're not touching.
they're not touching, right? And they can be also standing vertically, or it can be standing, or it can be lying horizontally, right? So not all bar graph you will see in that position. It could be on the horizontal side. Good? All right. So that is a bar graph. I'm going to use the same information and change it. So as it is, the bar graph can represent several things, as in different colors, as in different fruits, different probably persons that names begin with the letter A, B, C, D, or E, something like that. So it can represent those information graphically and visually, right? So you're not just saying, oh, we have 4 yellow marbles, 7 red marbles, 2 blue marbles. You're showing it physically that, okay, this is the amount of marbles we have. And you can have a visual picture of it. We have 4 of the yellow ones, 4 of the 7 of the red ones, 2 of the blue ones. Right? So let's go. So here we have a line chart, or a line graph. I should say line graph, whereby we would have, we were looking at the same information that we had before, but we can do it by saying, let's say, days of the week, right? And the number of students present in a particular class. Good. So the side, how many would be the number of students? Put it in. Number of students. And the category will be days of the week. Didn't change at the bottom. Not to worry about that yet. So, let's go. So we're working with number of students and days of the week, right? So we have Monday, Tuesday, Wednesday, Thursday, Friday. A, B, C, and D. Monday, Tuesday, Wednesday, Thursday, Friday. So let's read some information on. How many students were present on Monday?
4.
4. How many were present on Wednesday?
2.
2.
Which 2 days we had the same amount of students present?
Wednesday and
Friday.
Friday.
Wednesday and Friday. Which day we had the most students present?
Tuesday.
Tuesday. Which day we had the largest, between which 2 consecutive days? Do we know what consecutive means? Okay, right after the other. It happened just after the other one. So we didn't have a gap or a space. Today, tomorrow. Monday, Tuesday. Saturday, Sunday. 1, 2. If we say 1 and 4, would those 2 numbers be consecutive?
No.
No, because we have 1, 2, 3, 4. If we count in order, right? Good. So which 2 consecutive days we had the largest decline in students present? Largest declined. Pardon?
Wednesday.
Where and where?
From Tuesday to Wednesday.
Tuesday to Wednesday. Do you agree, Shamar?
From Tuesday to Wednesday.
Yeah.
Tuesday, Wednesday is...
We had the largest decline.
Yeah.
Okay. So we had 7 students present. That's a large number. And the following day, we had only 2 students. So if you were to randomly ask or even give a reason, probably what would be one of your reasons for such a large decrease? Tuesday, we had a large turnout. On Wednesday, we had a small turnout. If you had to get a reason, what could be a reason?
We had Portuguese Wednesday.
Pardon?
We had Portuguese Wednesday.
Good. You had Portuguese Wednesday. Maybe the students don't like Portuguese, right? So most of them stayed home. Yes.
Same thing.
Same thing with Portuguese?
Yeah.
Okay then. Or maybe the rain fell, right? And they had flooding. So most of the homes were flooded. So they weren't able to come out. All right? So if we're to look at the line graph as a big picture, what would you say? What could you say about it?
Each lines they touch a corner. The hours and the end corners.
All right. Yes, they connected to each other because from one row to the other one, right? So they're connecting. Look at it. Look at the graph. Tell me what else you can say about it.
It makes a triangle.
Pardon?
It makes a triangle.
Triangle. Okay, not that important because it's not closed.
Is one line going up but just touching different numbers?
One line going up but just touching each number. All right, we can say one line going up alone because remember it goes up and it might come down, right? But it kind of creates a pattern also. So you can look at it and you could say, okay, so on Monday we had 4, but yes, more persons came on Tuesday, but oh my gosh, look how many stayed home on Wednesday. All right, so some of them came out on Thursday, and then on Friday, maybe they had Portuguese again. So they stayed home again, right? So it had a up and down pattern, or if I might want to say and share with you, a fluctuation where it went up and down, up and down, up and down. Because remember, it could have been up. Let's look at it this way. Let's go. So this is a good class. This class has 8 students, and then you have 7 came the other day, 8 came, then 8, then maybe 8, right? So you see what is happening there?
Yeah.
They are more or less, let me see if you can tell me. Tell me. What about the students in that class?
They're like Portuguese?
They're like Portuguese, and they're more or less
Yeah. Well,
always present, consistent, right? So you would find that they're always there. However, maybe something would have, the B, on Tuesday, somebody probably fell ill, so they stayed at home, because we all know what we went through a few months back or a year back or so. So to say for safety's sake, they stayed home, right? But this is a class that persons come regularly. So I'll change also to show you Monday we had no students. Tuesday we had 6. Wednesday we had 7. Thursday we had 8. Friday we had 3. Right? So that's another pattern. Tell me something about that pattern. All right, let me give you the question. What happened on Monday?
No students came.
No students came to school. What happened between Monday to Thursday?
6 students came.
Okay.
So what's the key?
Look at it. Look at the graph of itself. What happened between Monday and Thursday?
Oh, no.
7 students came in total.
It kind of increased from 6 to 7.
Good. So, and right on from between Monday to, well, I shouldn't say Monday. Sorry, Tuesday to Thursday, we had an increase of the students that showed up on Tuesday, more showed up on Wednesday, and more showed up on Thursday. So over that period of time, you had a steady increase, right? From Tuesday, Wednesday, and Thursday, you had a steady increase. It went up all the time. But what happened Friday?
It went down.
That means?
Decrease.
That means
The students came.
that,
The students came.
so that would mean that students came on Friday?
Yes. Some.
Sure?
A decrease in students came.
Good. So on Friday, we had less students attending school. Right? Maybe because of Portuguese again. Good. So there we have a line graph. So how would you describe a line graph?
Kind of has. I was gonna say it kind of has
A pattern. Okay.
and it
It has a pattern that either goes up or down, or
Okay.
increase and decrease.
Okay, it shows a trend, if you would want to say, a trend by saying it either increase or decrease or constant, right? And it's represented by a line that may go up or down, one line. So do we have rectangular bars? No, we do not have rectangular bars. We just have lines. Okay. So, here we have a very simple and basic one. And this shows you clearly and also gives you a clear representation on the number of students. So on Monday, what happened there?
No, like
No students. All right, let me change some figure. That it's a little too simple from the first one. So let me. Good. Which day showed a great turnout?
Thursday.
Thursday. Which day had the least amount of turnouts? Students present?
Friday.
Friday. Huh?
You said
Or when?
Thursday.
I know. So Friday or Wednesday?
Wednesday.
Wednesday. Which day had no students turning out?
Friday.
On Friday. Which days we had between which days we had a steady increase?
Monday and Tuesday.
Okay, but that's just two. So we can also say Thursday and Wednesday and Thursday, right? But we do not have a consistent pattern there because we would probably need a third day to say yes, it was a steady one because we would have only used 2 days, right? How many students in all were present for the week? How many were present for the week? Yes. 21. Agree?
Yeah.
21. Okay. So this is a dot diagram where you basically put like dots or circles to represent it. It can also be represented by, that looks something just like this, but it is called a pictograph or picture chart, where you can have, for instance, we can have 5 bananas. So we would draw the bananas to represent the 5 bananas. 6 red socks. So you draw the socks. 2 blue balls. You draw 2 balls. And we have what? 8 leaves. 8 leaves. So you draw the leaves. So you actually see the picture and not the dots, right? When do you see the dots? It's a dot diagram, right? Or dot chart. When you see the pictures, it's a pictograph or picture chart, right? And then we go to the pie chart. The pie chart, as it speaks for itself. If we were to say in real life situation, what would you associate the pie chart with? Circle. What else?
Like maybe like real life.
Real life. You got home and your parent brought home this thing. And you say, oh, there's a pie chart. Huh?
A pie.
A pie? What else? A what? A pizza. A cake. Right? All those things can be cut into sections and even shared. Right? So the pie chart, as I said, it speaks for itself. It looks like a pie. It looks like a cake or a pizza or so. But however, to get your pie chart, you'll have to go an extra mile of calculating the size of the angle of the pie. Now remember we did angle when we did up, what was one of the type of angles we did?
Right.
Right angle, obtuse, straight angle, acute. Alright, so if we're to look at this pie, do we have any acute angles and which color?
Blue.
Blue,
Pink.
pink, anything else?
No.
No? What about the yellow?
Yeah, yellow.
What we know about an acute angle?
It's less than 90.
Great, it's less than 90. So let's get an obtuse angle.
Green.
No.
Green.
Yeah.
Green. Obtuse, what we know about an obtuse?
It's more than 90. And it's
That's 96. 18.
less than 180.
Yeah.
Do we have anything else, any other type of angle here?
A reflex angle.
A reflex angle. What do we know about a reflex angle?
The
It's measure more than 180.
It's more than 180. It's less than 270. Agree? It's just more than 180 but less than 360. What about a 360 angle?
that's the circle.
It's a point.
Yeah.
It creates a circular angle. Right, so there is where we have the pie. So in order for us to construct this pie or draw this pie, to get the correct measurement, we would have to do some extra calculation. So, right, so what we wouldn't be looking at that for today's session. Good, so what you can tell me about the pie if you're to describe it?
Made up of different sections.
Made up of different sections that we call sectors. That's a slice of the pie.
Yeah.
What else? What's the main thing about it? It's circular, right? So it wouldn't look like any of the other ones that would have the x-axis and the y-axis, right? So it's a circular. So, what is the which color is above 50%? Green. And what do we mean by 50%?
More than half.
It's half or more, right? Because I asked for more than 50%, right? Which color has the minority?
Blue.
Why? Why did you say blue?
Because it has less space.
Because blue has less space, you said? Okay, it's the smallest, right? Which colors are almost the same?
B and A. Yeah.
B and A. Agree? Shamar?
Yes.
All right. Good. So we had the bar graph, we had the line, we had the dot, and we had the pie. Right? Please keep these things in mind. So we have the histogram. What would you say about the histogram? Let me change back these figures that I have here. All right. So what could you tell me about the histogram?
They're all even numbers.
Even. Not really looking at that.
They're connected.
They are
Connected.
touching.
Yeah.
Same like the bars, because they are bars. Agree?
Yes.
But the bars are touching. Right? So, we can say, all right, we need the ages of the students in the school. But because we might have so many variation of the age, say we're at a primary and a secondary that is together, and we have the 3-year-old to 17-year-olds, right? So we can't write 1, 2, 3, 4, 5, 6, 7, 8, 10, blah, blah, blah. What we do, we could categorize it or group it. So we can say, well, we want the 3 to 8-year-olds, right? And we want the 9 to 12, or no, 9 to 13 years. Good? So the ages might kind of connect a little, because you might have one of the child can be 8 years, 11 months. Good? So they actually fall in between the 8-year and the 9-year-old child. Right? So they're in between there. So we connect it, because that child could be just at the middle to go over on the other side. Think we understand? Good. So the histogram, we have touching. So we can say probably on, where we won't say, let's use days of the week. We could probably use even in terms of the ages. So we have, at 4 to 6, we have students that are 3 years old. Right? Let's say, yes, just calling a figure. However, no, I shouldn't say that. We have students between the age of 4 to 6 years. So we have some 5-year-olds also. Right? That create that column there. We didn't change on the graph so that you can see it properly. But that is what I would explain to you. We have the 4 to 6-year-olds there. So we might have some 5-year-olds fall in between. So when all of them are added up, it's add up to 3. So we probably have one 4-year-old, one 5-year-old, and one 6-year-old. Right? You okay?
Yeah, allergies.
Allergies? Okay. Sorry about that. Right. So we had, what's the difference between the bar and the histogram?
The histogram bars are touching.
The histogram, the bars are touching, and the bar graph, the bars are
not touching.
not just not touching. What about it though?
They're
Equally spaced.
Yeah.
Agree? They're not touching. But then suppose this one is like this, and this one is like this. Right? They're equally spaced. Right? Good. So you would have seen the bar, the line, the dot, the pi, and the histogram. So we're going to do a little activity where I'm going to give you some raw data. Raw data are the figures that I'm going to give you to represent it on one of these graphs. Right?
Yes.
We there?
Yes, miss.
All right. So it's raw data because I'm just going to put a set of numbers on where you will copy it. Right? So let's say we have scores in a test where the highest mark would be 10. Right? So I'm going to put on a few. Well, let's go so high. Let's keep it a little lower than this. Copy those numbers quickly. All right. So first of all, we need to identify how many of what numbers we have, right? So let's go to the ones. How many ones we have?
2.
2.
2.
2, 2?
Yeah.
3.
3.
4.
3.
5.
1.
2.
2.
Sure?
Yes.
Yes.
6.
2.
2.
Great. Let's copy that. And you will be sketching our bar graph. Could I take off the raw data?
Yes, miss.
You have this, right? So we'll take a note of that. So to get our bar graph, what do we need? First of all, the vertical line, and the vertical line is called the, we have the horizontal would be the X, and the vertical the Y. And what are we dealing with?
Numbers.
What are we dealing with? Scores? What?
Oh, scores of a test.
All right. So this point here would always start from 0. Good? And we're looking at 1, 2. What is the highest?
10.
No.
6.
6? Mm-hmm.
Yeah.
3, 4, 5, 6. Agree?
Yes.
All right. And then we have 1, 2, 3, 4, 5. I don't think we had so much, right? In terms of the ones and so. We don't have so many numbers, right? All right, good. So because we're doing a bar graph, what we need not to happen,
To be touching.
we don't need the bars to be touching. But remember, we don't have a proper graph book here, right? So we're going to just try to estimate and keep a little space in between the bars. So how many ones we have?
2.
2 ones. So we go up to 2, right? Come over. So we keep that space there. Okay? It's not a proper graph book or graph page for you to get it accurate. So how many 2s we have?
2.
2.
So we have 2 1s and 2 2s.
Yeah.
Yes.
Up, over, and try to keep same amount of space. Right? Because of my graph and the drawing, let me try to get it a little more accurate looking. 1. Okay, sketch your own, put in the rest. Two. What are the numbers? 2, 2.
3 threes.
3, 3.
4 threes.
Oh, 4 threes.
Yes.
Yeah, 4 threes. 5 twos.
2 5s.
And
2 6.
yeah, 2 6.
So we have 2, 2, 2. All right. Good. So let's go to our screen now. Our screen is up. No, it isn't. We're having some difficulties for our screen to go up. Alright, since our screen is not up, I just wanted to show you, for you to verify if your graphs were drawn the same way as mine. Alright, and from observation, you would have recognized that your 1s and your 2s had 2. They occurred twice. Your 3 and 4.
Yeah.
3 and 4 was 3 times, same amount. 5 and 6 twice. So that means which scores were the highest?
3 and 4.
Yeah.
3 and 4. So we had how many students scored 3 and how many scored 4?
Only 3 and 4 scored 3.
Three students scored 3 marks, and 3 other students scored 4 marks. Agree? Alia? You're wondering? Yes. Remember the scores are 1, 2, 3, 4, 5, and 6.
Yeah.
Right? And the number of students that scored it were the ones on the y-axis.
Yeah.
Good? So, please do we're gonna use it. Not really appropriate, but we can use it just for graphing sake. We'll use that same information and make a line graph. Right? So draw your x and y axis again. So do we need bars now?
No,
No,
miss.
no.
No, we don't need bars. So, how many scores got 1?
How many schools got 1, 2?
How many persons, sorry, got 1?
2.
Okay. So, score 1 marks. 2 we said? So this is 1 and we want to go up to 2. So we go straight in line with 1, stop at 2, put a dot. Put a dot. Okay, put a dot. I know what you're thinking. You're thinking that we're not doing the dot graph, right?
Yeah.
All right. Because remember, we need to start from somewhere. So we can't draw a line from there. Because we don't know where we're going yet. So that's why you say put a dot. So at 2 is?
2.
2 is 2. So I'll put a dot again. So I move here to connect, start making my line. 3.
3.
3. We go straight up to from 3. Straight up to 3. Put a dot. Connect my line. Supposed to be with a rule. 4.
3.
3.
4 go up to 3. Join. Mm-hmm.
2 or 5. Is it
5 to 2. 5 goes to 2. Come back here. And 6 to
2.
6 to 2. So we go across there. So Shamari, see why we place the dots?
Yes, miss.
We just place the dots so that we can make the connections. So you would see that all the persons that would have scored 1 to 2 marks is consistent. Then we have more students would have scored 3 to 4 marks, and it went back down for the amount of students that scored 5 to 6 marks. So we would have a few students that scored between 1 to 2, a little more scored 3 and 4, and a few again scored 5 and 6. Alright? We there with the line? So this is your line graph. So please take a note, make your note. Good. So let's take that same information and do a dot. So we need our x and y axis again. Shamar, your y axis are falling. They're all leaning. So how do we represent the dot? So at 1, what do we do?
This dots.
How many?
2.
2 dots. So put 2 dots. At 2, we have
2 dots.
2 dots. 3.
3 dots.
4. 4,
3,
5,
2,
6,
2.
so we just have dots. You there, Shamar?
Yes, yes.
Good. And let's go to the histogram, because as I said, for the pi we would have to do a little calculation. So let's go to the histogram, because we're actually counting down on time. So the histogram, we need our bar, our x and y axis, sorry. Good. What about the histogram?
We use bars.
Yes, and what about the bars?
They aren't touch.
They're touching. So the first one is 1, right?
Yes.
No, 2, sorry, 2. So we go up to 2, and we can touch here. The other one is 2,
Yes.
up to 2, touch. The other one we go up to 3, and we would have to come across to 2 and carry it back down. Same for 4. Five, we have 2, and 6, 2. So they all will be touching. Right? So what are the graphs we looked at?
The bar graph.
We have the bar, we have the bar graph,
The dot.
we have the dot,
Pi.
the pie chart, line graphs or the line chart.
And
We have the pictographs. Yes. So, and they all are used to represent some sort of information, right? That you can even interpret or analyze by looking at the graph and reading off what the information you would have been given, right? So the graphs are useful for bringing out certain things within the information that you're sharing and for you to be able to analyze it. We there?
Yes.
Sure?
Yes.
Right. So, as I said, we were a function relation with mapping, then we go into graphing. So we would have done some graphs. So when we go back to function, we will be able to use our y and x axis to make our function and relation graph. Okay? So do have a blessed afternoon and enjoy. See you on Friday for English sessions. Enjoy.